Okay, so we are now going to look at some problems that are just a little bit more involved than what we were doing. And this is just to expose you to how probability can get more and more complicated. Okay, I'm not wanting to do anything terribly difficult, but I do want to give you an idea of what makes probability kind of an interesting subject here. So we're going to look at the example where you roll two dice. So like I just rolled a 4 and a 6, so that adds together to be 10, or that would be 8. That would be 5. So if you look here, I could roll, the smallest number I could roll would be a 2, and that would be a 1 and a 1 on both dice there. The largest number I could roll would be when I get like a 6 and a 6. That would be 12, okay? So I could roll from 2 to 12. Now my question is, are those equally likely? Like, would I be just as likely to roll a 12 as I would a 7? Okay? And the answer to that, of course, is no. You're actually more likely to roll a 7 than you are a 12. And the reason is because there's a lot of different ways of rolling a 7. Like I could roll a 1 and a 6, or I could roll a 2 and a 5, right? I could roll a 3 and a 4. Okay, so there's multiple ways of rolling a 7. There's only one way of rolling a 12. I got to get a 6 on both dice. And that is not as likely as getting a 7. Okay? And so what we need to do is we need to know what are all the possible outcomes of this experiment. Okay? And the outcomes here are the different ways you can roll the two dice. Okay? And so one way of knowing what all the possible outcomes are to make a table. Okay? Like this. Along the top, this will be the roll of one dice. So I'll have the numbers 1 through 6. And down the side, this would be the roll of the other dice. So I'll have the numbers 1 through 6. So we could say this is die 1, and up here maybe is die 2. Okay, so this is what I roll on my first dice. This is what I roll on my second dice. So if this were like the first dice and that were the second dice, I would have a 4 and a 2. So a 4 and a 2, and I would roll a 6. Okay? Another way you could do here is you could have two different colored dice. And maybe the white dice is die 1 and this is die 2. Right? A 4. Oh, look at that. There's a 4 and a 2 again. Let me try it again. Oh, there's a 2 and a 6. Okay? All these are different rolls. And so what I can do is I can just fill out my table. So I could roll a 1 and a 1, and that would be getting a 2. So that's actually the snake eyes right there. And then a 1 and a 2 would be 3. 1 and a 3 would be 4. 1 and 4 would be 5. This would be 6. And this would be 7. 2 and 1 would be 3. 2 and 2 would be 4. 2 and 3 would be 5. And you can see that these are just increasing by 1 as I go down. So 3 and 1 would be 4, and then I just increase by 1 each time. And then 4 and 1 would be 5. This would be 6, 7, 8, 9, 10. 5 and 1 would be 6. This would be 7, 8, 9, 10, 11. And 6 and 1 would be 7, 8, 9, 10, 11, and 12. Okay, so how many outcomes are there? Well, this is a 6 by 6 square. So if I take 6 times 6, I would get 36 outcomes to this experiment. Okay, the number, and this is, I'm multiplying the number of ways of rolling the first dice times the number of ways of rolling the second dice. Okay, and so there's 36 numbers inside my table here, and each one is an outcome. And so you can see that there's a whole lot of ways of rolling a 7. There's only one way of rolling a 12. That's what I showed earlier. Okay, and there's one way of rolling a 2. So those are the least likely. And these would be like 1 out of 36. So there's 1 out of 36 ways of rolling a 2, 1 out of 36 ways of rolling a 12. But the 7, and you can see they all occur on this diagonal. There's 1, 2, 3, 4, 5, 6 out of 36 ways of rolling a 7. And let's say rolling a 6, there's actually 5 out of 6 ways, or 5 out of 36 ways of rolling a 6. There's also 5 out of 36 ways of rolling an 8. So like the 6 and 5 have the same probability. Similarly, the 5s and the 9s have the same probability. The 4s and the 10s, the 3s and the 11s, and the 2 and the 12. So there's a lot of patterns in here, right? Math is the science of patterns. And so you can find all kinds of probabilities then. So I could say probability of rolling a, we'll say rolling a 9. So out of the 36, there's 1, 2, 3, 4 ways of rolling a 9. So 4 divided by 36 would be, this is 0.1111 if I round to 4 decimal places. 1/9. Okay, I could do probability of rolling a 7 or an 11, like at the casino. Okay, so out of the 36 outcomes, let's see. There's 1, 2, 3, 4, 5, 6 ways of rolling a 7, 2 ways of rolling an 11, so there would be 8 out of 36. And that's actually like 0.2222, 2 nines. Okay, I could do probability that the number that I roll is greater than or equal to 10. So it'd be like there's 3, 4, 5, 6. It'd be these numbers right here. There would be 6 out of 36. Okay, which would reduce down to 1, 6. So 1, 6. I'm sorry, 1, 6, 6, 7 would be that probability of rolling a number greater than or equal to 10. Or I could have an even number. What's the probability that it's an even number? So out of the 36, I have to count up how many are even. So the 2, the 4s, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there's 18 out of 36 ways. And you can see, in this case, it's still 1/2. Okay? But that wasn't obvious. I had to count all the even numbers in my table. So that's how you can find out the probability of rolling 2 6-sided dice, okay? Now here's kind of the neat thing. I actually have, these are 12-sided dice. They have the numbers 1 through 12 on them. And they actually have 12 sides. And you can roll them. So there's a 3 and a 7, so that's 10. A 7 and a 7 would be 14. A 1 and a 10 is 11. 10 and a 3 is 13. So there's all kinds of numbers that I could roll on these two 12-sided dice. Okay? And guess what? You could, and I'm not going to write out the whole table here, but you could list out all the possible outcomes. Right? This would be the numbers from 1 to 12. This would be the numbers from 1 to 12. Right? And then you could list out all these possible outcomes. Now the question is, how many outcomes would there be? Well, this is a 12 by 12 square, right? 12 by 12, that's 144 outcomes now. And the smallest outcome would be where you roll a 1 and a 1 on both dice, kind of snake eyes here, 2. The biggest outcome would be when you roll a 12 and a 12. So this down here, this corner would be 24. There would only be one way of getting 24. So even without listing out the whole table, I could find the probability of getting a 24. Right? It would be 1 out of 144, which would be fairly small. it would be like 0.0069. So pretty small chance. Okay, and you could fill out the table and find any other sort of probability that you would like to find. And that might have been off the screen. If it was, I'm sorry. But you get the idea that you have a 12 by 12 square, and you could find the probability. So you could do this with any. There's 10-sided dice. There's 4-sided dice. You could also do it with like a 6-sided dice and a 12-sided dice, right? Like 11 and 6, I'd get 17. And so the way that you would do this is you'd have the numbers 1 through 12 up here, and then the numbers 1 to 6 down here. And this would be, let's say, die 1, which is a 6-sided dice. We'll say this is die 2, which is the 12-sided dice, right? And then how many outcomes would you have? Well, you could figure this out. You would have 6 for the 6-sided dice, 12 for the 12-sided dice, and this would be equal to 72 outcomes. Right? And then this would be like snake eyes. The 6 and the 12 down here would be 18, and you'd have all these numbers in between. There would only be one way to roll the 18. You could find the probability of rolling an 18. It would be like 1 out of 72. 72 possible outcomes. And you would get like approximately 0.0139 if you round to 4 decimal places. Okay, and you could fill this out. You could answer other questions, but you see, there's a lot of possibilities with this table. And this is anytime you do 2 actions, like rolling 2 dice. And we're going to see in another video here that you can extend it to things other than dice as well. But this kind of leads in. You can see what I'm doing here is I'm multiplying the number of ways of doing each dice to get the total number of outcomes. This is actually a special case of something called the counting principle, and we're going to look at that in the next video.